All right, so let's delve into the first puzzle. So I still have one little slide here that just says that it turns out that basically, if we have these two ingredients, one is trade costs between countries, and then the second one is that foreign goods and goods from home are going to not be exactly the same. People are going to have preferences over those two goods, and of course, they'll substitute between them based on which one is more expensive or cheaper, but it won't be perfect. So even if foreign goods are very expensive, you're still going to consume a little bit of them. Okay. Um, what do we mean by trade costs here? Trade costs include both the actual costs of trade, like getting your goods loaded onto a ship and paying the freight and the insurance and all that good stuff, but also just the transactions costs to doing business with someone in another country. So that could be language, that could be culture, that could be simply just the additional time it takes for you to search for these people. I actually have some of my own research is about the cost of searching for clients abroad and how that shapes responses to trade shocks. It's fine to say that you have a good that you'd like to sell in China, but you have to find a Chinese firm to buy that good and to market it to retailers and the retailer to sell it. And it's not like you can just immediately find that person. You need to go to a trade show or start looking on the internet and sending emails, and there you can see that language can be an issue and culture can be an issue. So those can be important barriers to international trade, and that's what we're thinking about here. So models like that, very simple models we're going to write down, are going to explain the first four of those puzzles, the real puzzles. And then the last two puzzles, the price puzzles, we're not actually going to write any models down. It's just going to be intuition. And that's actually all there is in the original Obstfeld-Rogoff papers as well. So without further ado, let's move on and start looking at the first puzzle, which is home bias in international trade. So I've got a map here. This is, we're going to be talking about results from a paper, McCallum 1995. This map is just something I found that had Canadian provinces and US states. But this is sort of a famous paper that surprised a lot of economists and sort of generated a lot of further research. So what we're going to look at in this paper, I guess first of all, the yellow part of this map are the Canadian provinces where most Canadians live. It's the ones that are further south. And then all the US states. All right, and what you can see is there's provinces like British Columbia, where Vancouver is, which is very close to Washington, where Seattle is. And then there's, of course, Washington is a certain distance from, Chicago or something like that. So what you can do is you can look at the amount of trade that's done between, say, Vancouver, or British Columbia, where Vancouver is, and Ontario, where Toronto is the largest Canadian city. And then you can compare trade from British Columbia to trade with, say, what would be a good example? Maybe Austin, Texas, which is a similar distance from Vancouver. And Austin, Texas is maybe a similar size to Toronto. So we would sort of expect that if there were no trade barriers, if this were all just one single country, then it would be about the same amount of trade between Austin and Vancouver as there would be between Vancouver and Toronto. Okay, so that's what we're going to do. And of course, what we're going to see is that there's massively more trade between Vancouver and Toronto, or more formally, British Columbia and Ontario, than there is between British Columbia and Texas. Okay, and we can do that for lots of different pairs of locations. All right, so the headline finding from this McCallum paper is that there's 20 times more trade between Canadian provinces than there is between Canadian provinces and US states. Okay. So let's go ahead and look at the actual regression from the McCallum paper. So this is the specification for the regression. Xij is the amount of trade between I, which could be a province or a state, and j, which could be another province or another state. Okay, and this is all in logs. So we're going to have log trade between two provinces or states, a constant term, and then the log of the, say, total trade or total output in I, the log of total output in J, the distance between I and J, and I believe that's the log distance between I and J. And then finally, a dummy, which is 1 if I and J are in the same country. Okay, so we expect that this E here, this E term is going to be negative. Okay, and that's going to be sort of our measure of how large the cost of moving between countries is in terms of trade. So if we kind of just look at these findings, we find very, very standard findings for this type of estimation, which is known as a gravity equation. As a side note, the reason it's called a gravity equation is, now let's suppose that these are not logs, so this is going to be big X. I think that's a little smaller here. So this is not logs, this is in levels. This is the same as saying let's see here. It's equivalent to this model, and then let's think about how to put this dummy in. I think it's going to be, should be careful here. Okay, so this is an indicator variable if you're in the same country. Same country. And if you are, then you get an additional term, which is e to the power e, let's say exponential function to the power e. Okay, so this was a little bit awkward, but if we kind of ignore this term here, so let's ignore this unusual scalar for being in the same country. There's probably a cleaner way to do this, actually, but whatever, it doesn't matter. This is just for illustration. Look at this part of the equation here. This basically looks like the gravity equation. I mean, for gravity, like the physical force. If xij is the force, the gravitational force between two bodies, A here would be the gravitational constant, usually G in physics. Yi would be the mass of point I, Yj would be the mass of point J, B and C would be equal to 1. And then Dij is the distance between, body I and body J. And then D here would be 2, right? The square distance. So this thing here looks very, very close to the actual physics gravity equation. If you take logs of this thing, then you're going to get this equation here. Okay, so anyway, these are all very standard estimates you get from a gravity equation. Typically you find B and C are about equal to 1. So I think that I said that Xij is the log total trade between I and J. I think that here actually Xij is the log exports from I to J, which is why we can have a different coefficient B and C, right? It matters whether you're the importer or the exporter. But in any case, these findings are very standard. It's about 1. Both B and C are estimated to be around 1. The distance, this is usually estimated to be around -1. Here it's -1.5. That's within the realm of what is sort of standard for gravity equations in international trade. But then the really interesting thing is this dummy term here. So I said it should be negative, but actually if I and J are in the same country, we expect that to scale up trade. So we expect this to be positive, actually. And sure enough, it is positive. And you can see it's estimated to be around 3, just a little bit above 3 maybe. So what does that mean? Well, if we plug that back into this equation here, then you see that we actually have to take the exponential of e. So the actual number we get here is about e to the power 3, which is approximately equal to 20. So that says that if I and J, all else equal, if I and J are in the same country, then their trade will be 20 times higher than if I and J were in different countries. All right, so this was sort of a shocking result for people. Why is that? I think I have it on the next slide. What could be causing this difference? If you've ever been to, I mean, most of you probably haven't, but I've been on the border between the United States and Canada. It's not hard to cross the border. We have NAFTA, free trade agreement. So we should be careful. After NAFTA, this data that I just showed you is from before NAFTA, but after NAFTA, it's still like 12 times higher, the amount of trade between states or provinces in the same country. So it's like there's no tariffs. Driving across the border, there is a border check, but it's not a big deal. It adds marginally a little bit of time to your journey. I mean, people that are living in Canada sort of famously will drive to the United States, buy like beer and drive back to Canada because it's cheaper in the United States and things like that. So I mean, it's kind of crazy that it's a very simple land border. Both countries speak the same language, very similar culture, same types of television programs mostly. I'm from the northern part of the United States, and the culture where I'm from is even sort of more similar to Canadian culture than sort of standard American culture, you might say. But anyway, so it seems like it's very difficult to explain what could possibly be causing such a difference between being in the same country like Canada and trading across the border to the United States. 12 times more trade between otherwise similar locations in Canada. So and then here I say other countries, maybe it's lower. If we look at, say, most countries probably, actually I'm not quite exactly sure what I meant by this sentence here. I think that they've done similar studies like this, but for the EU. So say if we're looking at Denmark, so we're looking at trade between Aarhus and Copenhagen and comparing it to trade between Gothenburg and Copenhagen. Well, then the difference, it's still going to be like 2.5 times more trade between Aarhus and Copenhagen, even though it's very easy for goods to travel to Gothenburg, to Copenhagen, et cetera, et cetera. So it's not quite 12, but it's still 2.5, which is still really high. So basically, Opsahl and Rogoff are going to say, it's not actually that big of a puzzle at all. All we need is these two ingredients, that goods from abroad are not exactly the same as goods from home. They can enter symmetrically into your utility function, it's just that they're not the same goods. You have a substitutability between them. And there's trade costs, and that's actually going to be able to generate numbers that are of the size that we see here. Okay, so next we'll get into the model.